Hello and welcome to this 100th episode of Compiler Programming. Today I'm not gonna do any coding, instead I have a couple of announcements to make, and also what I wanted to do is go through the code and talk about what I think worked pretty well, what didn't work well, and where all of this is going in the future. So first thing is, now the code is actually open source, so if you missed something during the episode or you want to look up what happened, most of the time I labeled commits correctly, although I unfortunately have to admit that some of the commits are not correctly labeled with episodes, but I can't really do anything about that now. So if you're interested, go to GitHub. I will post the link to the project in the description of this video. And if you're interested, you can follow along there and look at the code as much as you want. You can also fork and experiment with your own stuff, as always. The code is licensed under an MIT license, and except for a very small piece of code inside of Prelude, which we also go through, the whole code is written by me, so there is like no weird licensing issues or anything like that. So that's the first thing, and next, I guess, is what is going to happen to this video series in the future. Over the 100 videos, I learned a lot. I understood a lot about what I'm trying to build, about how to make videos, hopefully, and also looking at some of the statistics on YouTube. Even though the total amount of views is not very high, I think I still can understand that there are certain topics that are more interesting to the people and topics that are less interesting to the people. And if I want to keep it up, it would be helpful if I took a more focused approach onto what I'm shown on the video versus what I'm not. So starting from now on, if you wish to follow the full development of the project, you can subscribe to notifications on GitHub, right? You can start and you can watch, and you will get notified about what is happening here. And then for the things that I think are interesting and could be helpful for people to learn, and just some tricky stuff, I will continue doing videos, but a lot of the development will now happen offline and inside the repository, which also means that you can contribute. For now, there is not really much setup for that, unfortunately, but this is also something I plan to work on, maybe to allow people to make easier contributions to the project. So that is the basic gist of it, and now I wanted to kind of go through the code that we have right now and talk about what I think is good, what is not, and a bit about C as well, and why I'm making the changes that I'm making. So I guess another reason why I want to start doing a lot of work on the language offline is that doing it in video is a rather slow process, so it takes a lot of time to get to anywhere. Like if you think about it, even 100 videos, let's say, be generous and say it's an hour per video. That means I literally just spent 3, maybe 4 weeks of real work, right, on the project, and that's not a lot. So I want to accelerate this quite a bit, and that requires work. And the reason I want to accelerate this is because over the past 1.5 years, I spent a lot of time working with C. And the thing I realized about C, and something that I also then heard echoed by other people and so proof of, is that you can totally be very productive in C. The big issue is that you would live in your own world. Like if you want to be productive in C, you basically have to set up the whole standard library by yourself, set up everything the way you want it to be set up, and it's very hard to bring in dependencies and interoperate with other code. And like all the people that I know are productive with C, they basically have their own world. So if I have to, build everything from scratch, then I would prefer to do it in my own language rather than doing it in C. So this is why I want to accelerate the development of the language itself and start sort of investing into that infrastructure as soon as I can, instead of investing in C, which I actually have no desire to work with long term. And this file that we're looking on, which we like sort of appeared in several videos, but I never really looked through. This is my version of build everything. This is a header file that contains type definitions, contains kind of all the stuff that exists also in standard headers of the C, but in my own flavor that I actually enjoy using. So this is coming from simple type definitions, and you have casts. I think that C casts are terrible and they should actually be checked. So these are checked C casts. They have assertions that they are compiled out in release mode, but in debug, if you try to, for example, cast from from a bigger number to a small number, if it doesn't fit, it will assert, and you have to deal with it. Obviously, you can do wrapping casts and whatnot, but those should be very explicit. I think Rust does it the right way, and this is how I'm approaching this. There's also this problem with min and max functions in C, so I have those for each of the types. Then this is just something I use for this editor actually. Then the next thing is what I learned from Zig, the Zig language, that it's very nice to have explicit allocators in C, and I was really enjoying this pattern. I think it's really good and something I don't really see in other languages, and I don't think it's a good idea to not have it explicit, because majority of the time you are not dealing with memory kind of one-off, right? Very often lifetime of your structs and data is tied to each other. So you have some kind of root struct or root objects, if you want to be object-oriented, that owns a lot of things that are connected to it. And when this object goes away, then you have a cascade of things that you need to clean up. Now in C++, that literally means that you have a cascade of destructors, as it sometimes is very huge. And you can see it very prominently, like if you close the application and it takes, I don't know, 5-10 seconds to close sometimes, or if it's a multi-window application, you start to close the window and that happens. But if instead you attach that to have a window global allocator, let's say, and you just, all the objects that are belonging to that window are grouped together there, then whenever this window is closed, you just execute one call to clear memory and you're done. Obviously, in real code, it's not as simple as that, but the pattern still holds pretty well, and you'd be surprised how little allocations you can make if you do this right. Hopefully, as the compiler is getting more mature, I will start using the pattern that we have right now, which is basically, I'm just gonna, allocate all the memory and I'm not gonna care about cleaning up. I mean, that gets actually pretty far, as I think Git never cleans up memory. So for a command line tool, it's perfectly okay not to clean it up. But if we would want to have some kind of interactive mode or something like that, then memory management would become important. Obviously, there are multiple flavors of arrays that you need to have. So all of this code will need to be ported to mass at some point in time. But one thing to note is that there are technically a lot of macros here, and this for me shows two things. One, that C is not really a great language, but two is that a lot of this stuff is not very complicated, and macro based approach is a way to get pretty complicated features into the language that originally does not support them. And this is kind of the whole idea behind Mass, the language that I'm trying to write, to allow people to be able to add those complicated features into language. Okay, what else interesting we have here? So slice is something that we're using not just a bunch of bytes. And yeah. So there is string manipulation is pretty terrible in C, so I had to write out my own. What else is here? Yeah, Unicode situation is a bit unfortunate, I think. Probably it's worth its own video, so we won't go too much through it, but for a lot of applications, I think having basic ability to decode and code UTF-8 and UTF-16 is pretty much all you need for Unicode, but there are interesting cases everywhere, of course. Anyhow, LPEG is an experiment that I had, which also deserves probably its own video at some point. It's about parsing. And then we have a bunch of fixed buffer stuff. And yeah, I guess that's about it, what I want to tell about Prelude. So let's just pick up the next file. And we have, well, we'll just start by the alphabetical order. So the stuff inside encoding, I'm actually pretty happy with. I think this is a pattern that could carry us very far. I'm not yet very familiar with floating point stuff and vex instructions. Maybe there are no real patterns there, so we will not be able to have kind of logic here and instead have to rely on lookups, just gigantic lookup tables. But that's something we can see in the future. Even if that is true, majority of the instructions that you're writing are actually non-vectorized instructions and not floating points, at least unless you're writing a game engine or something. And even then, I think majority of stuff will be arithmetic and move instructions. There are some nice articles, I think, maybe I should find one where it explains that, like, basically majority of your program is moves anyway. So yeah, I'm pretty happy with this part. There is obviously lots still to do here, but it's a nice start. Okay, so function.c. This is a bit of a kitchen sink of all the things and definitely requires a factoring, which is something I will start slowly tackling off screen probably. But I like the basic setup again. It's we are able to construct functions in a pretty decent way. There is a way to import stuff, and there is a way to have these basic building blocks of language that I hope to later move on into macro systems. So long term, what I want to happen is that there is a very, very thin layer inside the compiler that just knows how to do macro expansions and maybe provides some simple things like maps and arrays of stuff, so you can store and look up stuff in your program. But the rest of it, or as much of it as possible, I want to do through macro expansion eventually. So even things like if, it is probably possible to just delegate more and more towards that area. Yeah, there is lots to do with the arithmetic. We don't have 16-bit values. We don't have unsigned numbers, which are interesting in their own right, and there is stuff with like double width multiplication. So when you get a result that is for example, if you multiply two 64-bit values, you actually can get one 28-bit result. And it's not really something that is even accessible in C very easily, as far as I understand, but it's definitely something to consider as a useful thing. Division it's more or less okay, but obviously, yeah, there is an unsigned version of it. And another very big topic that is pending is register allocation. And I'm still haven't decided what to do about the register allocation. On one hand, it would be nice to do it earlier, because if we don't do it, then I might run into a wall a bit later. On the other hand, register allocation complicates everything, so the development of other features will suffer. And I don't know what the right balance here, and also I don't know how I want to implement it, because I could do something as simple as like a FIFO or LIFO register allocation, or maybe something more complicated, but all that has its own interesting challenges. So register allocation is a very, very big topic, and there is like a perfect way to do it, but that perfect way to do it is also very, very, very computationally expensive, requires a lot of support structures and things like that. Comparison obviously needs to be extended to have all of them, not just the ones that are here. And yeah, there is definitely stuff to do around functions. So there is this fixed me. Right now we don't have higher order functions, so passing a function to a function is not something that is working right now, but that shouldn't be too hard. Overload matching ended up being quite easy, and at least right now, I'm pretty happy with how this works. Maybe we'll have to extend these score setup, so we'll have like another one for subclasses if such a thing will even happen in this language, which I'm not sure about. Probably I'll go more towards traits like Rust or type classes, Haskell, whatever. What else can I tell about functions? I guess that's it. There's definitely lots to do with structs and with algebraic data types, or tagged unions, how they're called. But it's a good setup at the moment. I will skip the H file because it's the same thing. Spec is also can be skipped. So next one is instruction. This file, as I mentioned in early episodes, is something that should be auto-generated, and maybe that would be an interesting video to make. But for now, again, format is not the most efficient one or the best one, but it works pretty well so far, and something I'm okay with. We have the beginnings of the CLI, and I'm pretty happy with how slim it is. The majority of the logic is elsewhere. And here we just say, okay, you passed us a file, we try to read it, and we try to compile it. I think this is nice, and I'm super happy about this run mode, which means that hopefully later on we are able to use this for places that, for example, where previously we would have BAT files, and this eventually will allow cross-platform stuff. And speaking of cross-platform stuff, so right now we are only able to output P32 files for Windows. There is obviously other formats. For Linux that would be ELF files, I think, and for Mac is Mac-O formats. Both of them have somewhat similar structure, not exactly, but I think that wouldn't be too hard to implement once we have this setup. So yeah, P32 stuff is pretty good. I'm kind of happy that I was able to like pre-calculate all the sizes of all the sections, so we don't have to patch the file afterwards, and instead everything is sort of written out right away. I still write it to the buffer instead of writing it directly to the file. I think as long as the final executable is not like 2 gigs of size, that is perfectly fine. When we get to the sizes, if we get to the sizes, then this is something to be fixed. But right now it's really, really unimportant. I think that operating system's virtual memory is good enough to handle this stuff. So yeah, this is pretty okay. One thing that is definitely missing right now, and something I have absolutely no experience with, so this will be a big research effort for me and trying to understand how that works, is debugging. So I understand in theory how it works. I understand that you have to generate debug symbols, and for Windows that would be a PDB file that have no public specification. There is one that is from LVM or LDB project, and I have to look into that, but that's gonna be pretty annoying and time-consuming thing to figure out how to correctly generate them, because again, I don't want to be pulling LVM into this project, and that means that PDB files have to be generated ourselves, and it's always fun to work with undocumented formats. Okay, what do we have here? So this is the most recent part of work. I think scope is perfectly fine. The whole tokenization also is pretty good. I'm not yet sure that the way that operators are parsed is the best one. So right now what we are doing is we are grouping all the symbols. So if you have like, for example, 3 exclamation marks, then this would be parsed as one operator. And maybe the better way would be to go the way the Rust goes, where even if you have it like that, the tokenizer recognizes this as 3 individual operators, and then the next section will be grouping them together. And since we already have these mechanisms to have post-processing steps on the tokenizer, maybe that would be a better option, but I'm not sure. Okay, what else here? It's nice that we have location and tokenizer. Would be important to make sure that we propagate that location everywhere else, because if we are gonna have debug symbols, and we should have debug symbols at some point, that will be required part of that you actually able to say, okay, I'm pausing on this line and this statement, and I want to know what does it correspond to in the source code. Yeah, so this is the tokenizer. It's pretty small and I think it's okay. Now we are going into the meat of it, where I'm doing kind of continuous rewriting of tokens that we get from the tokenizer by matching patterns in particular order. And as I mentioned in a couple of previous videos, I think that I like the general approach that we can very easily add new patterns, and including like being able to specify new macros like we did with a while macro. Well, that is certainly true. I think that it needs to be either changed completely, or maybe just grouped into precedence groups, kind of. So in the single precedence, we go for all the patterns, like plus and minus need to be in the same one, same as multiply and divide. And the reason that needs to happen is not really mathematical, kind of, because in mathematics it doesn't really matter if you first do, for example, all multiplication and you then divide, but the thing is, since we're dealing with computers and you have precision and you have overflows and you have all kinds of stuff like this, it actually matters that you do it in the right order. There is a common example that division by 3 and multiplying by 6 is not the same as multiplying by 2, as strange as it sounds from a mathematical standpoint. Okay. So yeah, this is something that needs to be looked into and experimented. So let's see how that would work. Also, macro probably will need to be folded into the same setup that they actually also have precedence. And you can say, this macro should only be applied like after the plus and has lower precedence to that. So something to do. Okay. The rest, I guess, here is not much to talk about because it just implements a bunch of syntax stuff. I guess the only thing is, even though I tried already to abstract away some of the logic and make it more compact, it is still, there is a lot of repetition, and maybe there is some opportunity to compact it even further and improve it like that. Okay, I guess that's about it for the source. We can skip this stuff, and we are only left with value. And yeah, this file is pretty okay. Most of the stuff makes sense. We have definitions for registers. We have helper functions to reserve memory on stack, reserve memory on the reserve register. And I imagine that this is this very basic level that is going to be kept in the compiler, and then macro system will just interact with it later on. Yeah, I guess that's all for the review. As said, there is lots, as you see, there is lots to do in the future, and some of it I will do off videos. Some that I find would be helpful for people to learn about, or there is not much information. I will do some videos, I guess, or there will be a mix of those where I'll do research off video and actual implementation there. A good candidate for that would be, I guess, debugging at some point, but it is a tough nut to crack. Guess that's all I wanted to say for today. Thank you for sticking with me if you watched it far, and hopefully I see you with the next episodes in a new format. And again, if you're interested in the project, please check out the source code, check out the repo, star it, and talk to you either in issues or in comments or wherever else you want. Thank you very much, and see you next time.